In question 4 of tutorial 2, a slab of mass m1 of 40 kilograms rests on a frictionless floor, while another block m2 of 10 kilograms rests on top of the slab. The coefficients of static and kinetic friction are given, and the upper block is pulled by a horizontal force F. The first task we need to do in this question is to first determine the maximum threshold friction it can withstand, so that we know whether or not to use static or kinetic friction in our calculations. So we first consider the static friction case to find its maximum value. Since there is no relative motion in static friction, A1 is equals to A2. We attempt to draw the free body diagrams for both the upper and lower block. Starting with the upper block, the mass is M2. There are two forces acting on the upper block. Firstly is the applied horizontal force F. And secondly, the static friction that is opposing this force. Since the whole block is sitting on M1 and the entire combination slides over the smooth surface, there is a non-zero acceleration. So we get Newton's law, which includes a non-zero acceleration term ma on the right hand side. This is equation 1. Next, we draw the free body diagram on the lower block. There is only one force acting on it, which is the static friction between M2 and M1. So the Newton's law equation is simply Fs equals to ma. This is equation 2. So we have two equations with two unknowns, namely F and A. We can eliminate A by dividing the two equations, then solve for F. And remember that the forces here refers to static friction, which takes a range from 0 to a maximum value. In order to determine this maximum value, we replace Fs with mu s times n. Then the applied force would correspondingly be the maximum threshold force one can apply on the system without breaking static friction. If the applied force exceeds this value, the static friction will fail and kinetic friction will occur. The value of n needs to be determined. It is simply equal to the weight of m2 based on the vertical forces on the free body diagram drawn for the upper block. So the maximum threshold force F is given by this expression, which we can now substitute the given quantities to determine its numerical value. So we have found that the maximum threshold force for this system is 73.6 newtons. In part A, the applied force is 100 newtons, which is larger than 73.6. So the threshold is exceeded and kinetic friction will occur in part A. For kinetic friction, the accelerations are not equal, so we can determine them by drawing separate free body diagrams. For the upper block, the net force is 100 minus the static friction force, and that will be equals to ma. Substituting in the given quantities, we can obtain A2 equals to 6.08 meters per second squared. Then for the free body diagram of the lower block, there's only one force acting on it, which is the kinetic friction between M2 and M1. Again, using the value of n which we have determined earlier, we get A1 equals to 0.98 meters per second squared. Finally, in part B, the applied force is smaller than the maximum threshold for static friction. So static friction is occurring and both blocks are moving with the same acceleration. So we can treat the two blocks as moving together in one overall mass, m1 plus m2. And finally, the acceleration is 1.20 meters per second squared.